Okay, chapter 20, cylinder, cone and sphere. We're learning about surface area and volume. So let us see what is volume
Space
first.
occupied.
What's the definition of the word volume?
Space occupied by the substance.
Okay, space occupied by an object. Object means a three-dimensional shape. Okay, so if you have many three-dimensional shapes, cube, cuboid, pyramids, cone, sphere, cylinder. So you're learning about these three shapes. Now, how do you find the volume? To find the volume, you have to multiply three perpendicular sides. Okay, multiply three perpendicular sides. Okay, now there's another way to find the volume. That is, you can do area into the third side. How does this work? Is because area is already the product of two perpendicular sides, and then you multiply the third side, it becomes volume, right? You understood, Aman? So this area we call it as area of cross section. For example, you take a cylinder. Yeah, this is a cylinder over here in my hand. Okay. So if the cylinder was flat, it would be a circle. Correct. Or also you can think of it like this. If you cut the cylinder like this, the shape that you get when you cut it is a circle. So the area of the circle would be the area of the cross section. You multiply that with the third dimension. The third dimension would be the height. So area of cross section into the height, you will get the volume of the cylinder. You understand? So that formula can be used to derive any volume formula for any shape. Area of cross section into the third side or the third dimension. So let's look at cylinder. Okay, for a cylinder, what would be the formula for volume? So what is the area of cross section of a cylinder? What shape is the cross section? It's a circle, right? So area of the circle into the height. What is the area of circle formula?
Pi r square.
What is pi r square?
Area of
Cross
circle.
section or area of circle. Since the circle is the cross section is a circle. Area of cross section multiplied with the third dimension. What's the third dimension in this cylinder? The height. Height is from the top till the bottom. So into h. That will be the formula for volume of cylinder. Pi r square h. Volume is pi r square h. Okay. Next, what is surface area? Surface area means the area of the surface. Okay. Now, how many surfaces does a cylinder have? So bottom surface, this curved surface, and the top surface. There are totally three surfaces. Okay. Just like how we wrote volume is area of cross section into third side, there's one more formula, that is the surface, the curved surface area, CSA. Curved surface area. Look at this. Just look at this shape over here. Curved surface area means this curved part, the area of this curved part. To find the area of the curved part, what you have to do is the circumference of the circle, you multiply it with the height. That's the formula to find curved surface area. How is that? Circumference of the circle, that is this ring, the distance of this ring. That value multiplied with the height will give you the curved surface area. Is that clear? So what will be the formula for curved surface area? Circumference. What is circumference of a circle? 2 pi r. Remember 2 pi r is the circumference of a circle formula. You've learned that in smaller classes. All right, so 2 pi r you have to multiply it with what? Multiply with the height. Okay, so curved surface area formula is 2 pi r h. Is that clear? Next, you have total surface area. For total surface area, you will add all the three surfaces. The bottom surface, the curved surface, and the top surface. There are three surfaces. So let's add everything. What is the formula for the bottom surface area? What is the shape at the bottom? Circle. So area of
Circle. Pi r square h.
pi r square. No. Area of circle is what?
Pi r square.
Pi r square. Similarly, top also there's a circle. Okay. Let me just write it like this. Uh, Bottom circle plus the top circle plus the curved surface area. Okay. So bottom circle's area is what?
Pi r square.
Pi r square. Plus the top circle? Pi r
Pi
square.
r
Plus the curved surface area?
2 pi r h.
2 pi r h. You add all these three, you will get the total surface area. You see, you can't memorize and mug up these formulas. It's better to derive them based on the question. You have to understand how we got these formulas. For example, if I ask you what is the surface area of this particular dabba here, what is this? Pen holder. How many surfaces does it have? If you look at it actually, there is a bottom surface, there's a curved surface, but there is no top surface. It's hollow, it's open. So we will not add one of the top. It will just be what? Pi r square plus 2 pi r h. You understand? So like that, you have to derive the formula based on the question, based on the requirement. Now, say you're finding total surface area. We have to write it like this. Then we have to simplify it. So can we simplify this formula? If you add pi r square plus pi r square, what does it become? 2 pi r square. Correct. Plus this one, that is 2 pi r h. Now, can we simplify it further? What can we do? Take common terms out. Which are the common terms?
Pi 2 pi.
Pi r is common. So what is remaining inside here? There is one r.
R
Here there is
plus
h.
h.
So this will be the formula for total surface area. Do you understand? But don't mug up this formula. You have to derive the formula. So you have to write this one and then derive it, and then you substitute the values, find the missing value. Okay. So these are all the formulas that you need to know for cylinder. Write it down. Questions won't be simply like, okay, find the volume, find the surface area, find total surface area. They will not give you direct questions. It will be something else only. Look at the questions. We'll just read the questions to understand what type of questions can come. First one is direct, okay? But they won't ask like that. Second one, look. The inner radius of a pipe is 2.1 centimeter. How much water can 12 meter of this pipe hold? It's actually a direct question only. What have they given? They gave radius and the length of the pipe. If you put the pipe straight, then it becomes the height of the pipe. So they have given height and radius, and you have to find how much water it can hold, which means that is the volume. So you can directly use the volume formula. You have radius, you have height. Okay. Now look at the next question. A cylinder of circumference 8 and length 21 rolls without sliding for 4.5 seconds at the rate of 9 complete rounds per second. See, now they have something to do with speed also. Find the distance traveled by the cylinder in 4.5 seconds and the area covered by the cylinder in 4.5 seconds. Okay, so you have to understand the concept that when something rolls, the distance it covers will be equal to the circumference of that circle. You understand? The distance it rolls in one oscillation will be the circumference of the circle. So like that, you have to convert circumference into distance. Okay. If you divide the total distance with the circumference, you will get the number of rotations. You understand? Let me say that again. Say the circumference is 5 centimeters. If it makes one rotation, the distance it will cover is 5 centimeters. What if it makes two rotations? Then how much distance will it cover? 10 centimeters. So the relationship is how the total distance it covered, 10, divided by the circumference 5, will be 2, which is the number of rotations. You saw that? So like that, you can use that concept over here. And based on time also. Time is also there, like in how much time it rotates and all that. Okay, so there are no fixed formulas for all this. This chapter has the most thinking, is the most thinking chapter. Okay, you have to think to do this. Last year, I just omitted this whole chapter because my students were not capable of thinking. Like what formulas I give, they were somehow doing it. I mean, they were weak because I directly taught them in 10th standard. So they did not know 7th, 8th, 9th standard portions. So it was very difficult, but somehow they passed. Okay. So this thinking chapter will only come if you are thinking all the way from childhood till now. If you suddenly start thinking now, you cannot do this chapter. That's what I'm saying. Okay. So try doing as many questions as you can from using the cylinder formula. So you can do 1, 2, 3, 4. Look at the fourth one. Again, I'm saying there are no formulas. You have to derive the formulas based on the question and make it. Okay. Okay. How many cubic meters of earth must be dug out to make a well 28-meter deep and 2.8-meter diameter? So that is volume only, right? They have given the height, that is 28-meter deep. They've given the diameter, 2.8 meters diameter. So radius will be half of that. Also find the cost of plastering its inner surface at 4.5 per square meter. So how many surfaces does it have, this well? Only the curved part. Normally the bottom part of the well, we don't plaster it. Then the well will not have water to come in if you're plastering it from down, right? So you're only plastering the curved surface area. So you have to find the curved surface area and multiply that area with 4.5. That will give you the total cost of plastering it. Got it? Find the curved surface area and multiply with 4.8. Yeah. So this is one. Then the fifth question is a different type of question. If you melt a solid and you make so many smaller solids with it, what will be same for this big solid and these small solids that you melted and made? The volume. Because you're using the same material to make the big and the small shapes, right? So the volume of the big shape will be equal to the total volume of the smaller shapes. So the formula that you can have is number of shapes, number of objects that you can make is volume of the big shape divided by volume of one small shape. Understand? If the big shape's volume is 10 centimeter cube and the small ones that you made is 2 centimeter cube. So how many small ones can you make? If one is big one is 10 and small one is 2. 10 divided by 2 will be 5. So you can make 5 objects with that. So this is another formula that is used in some of these questions. Okay. Total question number 8 from your book. Again, it's not very easy. Think and do it. If you're not getting it, I can explain a little bit, but that's all I can. And if it comes in the exam, something different comes, you should be able to think and do it. Yeah. In the last class, we saw a normal cylinder, the formulas for a normal cylinder, right? There were so many formulas. Where is it? This one, right? Volume, curved surface area, total surface area. What about a hollow cylinder? A hollow cylinder means it will be empty inside. So something like this, right? There will be a hollow space inside. So for this hollow cylinder, let us see what is the formula for volume, surface area. Okay, volume and surface area. What will be the volume formula? Now you have to derive it. As I said, there's so much to derive. See, imagine a cylinder, and from that cylinder, you're removing the middle part of it. So the volume of the cylinder will be the whole cylinder's volume minus that cylinder that you have removed from inside. Correct? So what is the whole cylinder's formula? Pi r square h. Okay, now we have two radii. The outer radius is capital R and the inner radius will be small r. So here also the outer cylinder's radius is r, capital R. So pi r square h and minus the inner cylinder, that is pi small r square h. Do you understand? Clear? Capital R is the radius of the outer and small r is the inner one. Okay, so simplify this. Pi is common. Is r common? No, both the r's are different. H is common. So then inside what do you have? R square minus r square. This is enough. Or if you want to be more creative, you can change that. This is in the form of a square minus b square. So you can write it as what? A plus b into a minus b. Remember that identity. A square minus b square is a plus b into a minus b. So you can use this anyone. as a volume formula? This one or this one? Write this down. Okay, next surface. How many surfaces does this have? 3, which all? Top, down, and outside. What about inside? Inside also there's a surface, no now? Because you removed that cylinder from inside, so there is one internal surface also. Okay, so we need, if you want to find total surface area, you have to add all the 4 surfaces. Okay, so let us find, we'll find each surface separately. Okay, we'll find the external surface area, then we'll find the internal surface area, then we'll find the top, and then and top and down is the same thing. Correct? Okay, so what is the external surface area? This outer portion. Last time we saw the formula to find surface area. How do you find the surface area? Curved surface area. Circumference into the height. Circumference is 2 pi r into the height. Same way, internal surface area will be what? 2 pi small r into h. Then the top and down. The top, what shape is it? Circle with the circle removed from inside. So it is the outer circle's area minus the inner circle's area. Correct? That will be what? Outer circle's area will be pi r square minus the inner circle's area, which is pi r square. Okay. You can take common pi, pi common outside, and then r square minus r square. Okay, so this will be the surface area. So external surface area, internal surface area, and the top down. So now what will be the formula for total surface area? External surface area plus internal surface area plus the top plus the bottom or down. Okay, so that is 2 pi capital RH plus 2 pi small rh plus top is pi into r square minus r square, and down is also pi into r square minus r square. Did you see how big formula it is? We just added all the 4. Now if you want to simplify this, from the first 2 you can take out 2 pi h common, and remaining you have capital R plus small r. And from the next 2, these 2 are exactly the same. So you can just put 2 of them. 2 pi r square minus r square. This is the full formula for total surface area. Should we memorize it or derive it? You have to derive it. Because it's, I mean, I can't memorize this whole thing. It will be confusing. Okay? All right. Just write down this much and then we'll do that sum. You guys just rejoin the meeting. All right. So let's do this question. What length of solid cylinder 2 centimeter in diameter must be taken to recast into a hollow cylinder of external diameter 20 centimeter, which is 0.25 centimeter thick and 15 centimeter long? So you're taking one cylinder and melting it and making another cylinder, hollow cylinder. So what is same for both the cylinders? But for both the shapes? The volume, right? Whenever you melt something and change it into something else, they both will have the same volume. Okay, so we need to write that statement. Volume of cylinder is equal to volume of hollow cylinder. That's where we start off. Okay. Before that, draw the cylinders with all the values given. Don't just write it, you draw it. So here's your first cylinder. Then here's the hollow cylinder. Okay, so for this cylinder, radius, I mean, diameter is 2 centimeter. That means radius is 1 centimeter. So the question is, what is this one's length? Length or height? That's what we have to find. That's all we have and we need for this. Now for the hollow cylinder, what all is there? External diameter 20. So from center till here is 20 centimeter. Then what is given? Thickness 0.25. Thickness means from here to here. That is 0.25. So how much will be the internal radius? Huh? See, external capital R is 20 centimeter. That is external radius. The thickness of this cylinder is 0.25 centimeters. 0.25. So what will be the internal radius? Small r. You have to minus this. Correct. So it will be 19.75 centimeters. Okay, that is the internal radius. And the length is 15 centimeter. Length means height is 15 centimeters. Okay, so these are all the values that we have. Now your statement is what? Volume of cylinder is equal to volume of hollow cylinder. And then you write the formula, substitute the values. What's the volume of cylinder? Pi r square h. And volume of hollow cylinder? It's the outer pi h into r square minus r square. Then you put all the values. See, pi we can cut it off here itself. Okay, so then we don't have to put that. So 1 square into h is equal to 15. Are both the heights same? Is the h of the cylinder and the h of the cylinder same? No. They're two different values, so you can't cut. Okay, whatever is same, you can cut. I use the a plus b into a minus b formula. Don't know if it will become easier. I'm getting the same answer only. Whichever way. Oh, okay. External diameter 20 centimeter. What? You saw it before? Yeah. What we took 20 centimeters? Radius. So diameter is supposed to be how much? 10. Okay, so this is 10 and the internal radius will be 9.75. Okay. Okay, you can make that change, go try it out at home. You understood how to do it? Okay. So you have to derive an equation, derive a formula. So here we derive the equation. The equation is what? Volume of cylinder was equal to volume of hollow cylinder. Let me do it, okay? So we will end with this. Keep doing more sums. I've explained to you full block cylinder and hollow cylinder. So you can do any questions that has these two. Okay. We'll end with this. Okay, you can continue at home. Please do as much as you can from the chapter. Beryl, you heard me? Solve as many questions as you can from here. Another 5, 6 more you do every day. Then tomorrow I might see you or not. Okay. All right. Bye everyone. See you.
Bye.
Bye. Okay, question number 9. A cylindrical container with internal radius of its base as 10 centimeter contains water up to a height of 7 centimeter. Find the area of the wet surface of the cylinder. Okay, do you understand the question? So there's a cylinder here. Its internal radius of its base is 10 centimeter. Okay, so that means radius from here to here is 10 centimeter. It contains water up to a height of 7 centimeters. So the height of till where the water is. Okay, that height is 7 centimeters. Find the area of the wet surface of the cylinder. Okay, how do we find this? How many surfaces are wet? Come on, Ryan, Nathan, Sneha, put your cameras on. Come on. I said this chapter you have to think a lot. Okay, you can't just put formula and substitute and get. You have to derive the formula. You have to make the formula with the values given. Yeah. So how do we do this? Formula, I'll tell you. Think of the logic. Which is a wet surface? It is a glass. Cylindrical. Which surface is wet? Down is wet. That's it. Okay, the sides. Okay, from inside.
Right.
So two surfaces are wet. Okay, so you have to find the surface area. So which all surface area? The bottom surface plus the sides, wherever the water is touching. Right. So what is the bottom? How do you find the surface area of this bottom part? What shape is this? So you have to find area of the circle. Area of circle formula is pi r square. And sides. Sides means the curved surface area. Why late?
I forgot.
I forgot. So the curved surface, we are finding the surface area of a bottle where the water is touching. So water is touching the bottom part and as well as the curved surface part. So this curved surface area's formula is what? Come on, we saw the formulas. Twice we have seen. The circumference into the height. 2 pi r is the circumference into the height. Okay, so this is the formula. Now, we can simplify the formula by taking common values outside. So pi r is common. Pi is same in both, r is same in both. It's the radius. So pi r, we can take it outside and then inside we have r plus 2h. Correct? Okay, so that's now sometimes they'll tell you what value to take for pi. If they don't tell you, then you will take 22 upon 7. So 22 upon 7 multiplied with r. How much is the radius? 10 centimeter into radius plus 2 into height. Height, we don't care about the whole height of the container. We only have to see the height at which the water level is. So here, the water is up to a height of 7 centimeters because we are finding which the surface area of the mug, what is cylinder, where the water is touching, right? So that is, yes. Did you understand? Okay. Have you already done this? Okay, finish it fast, Aman. Tell me the answer. So, yeah, I'll just quickly explain what we just did. The question was just to find out how much surface area of the container is the water touching. Water in a cylinder. So the water is touching two surfaces. The bottom surface, which is pi r square, and the curved surface, which is 2 pi r h. So we just had to find that whole thing, okay? So unfortunately, the answer comes in decimals. You can solve it and get the answer. 754.285, correct. Okay, yeah, correct. 754.285, all in centimeters, so centimeter square. Okay, you can try it out if you didn't get it. Let's go to another question, number 11. The height and the radius of the base of a cylinder are in the ratio 3:1. If its volume is 1029 pi centimeter cube, find its total surface area. Okay, so this is a cylinder. We don't know the exact values. What we know is that the height and radius are in the ratio. So if height is 3x, then the radius will be 1x. Okay, that's all we know. Ratio means you have to put x, right? So 3x and 1x are the height and ratio. The volume is 1029 pi centimeter cube. So they have not put the value for pi, they're just substituting pi. Find the total surface area. Okay, what's the formula for total surface area for a cylinder? There are how many surfaces? Okay. Anyway, to find the surface area, we need the height, we need the radius. We don't have the height, we don't have the radius. We have volume. See, volume is a derived value. The height and radius are simple values. The volume, surface area, all these formulas based values, they are derived values, right? So since volume is given, we have to first use the volume formula and find the missing value. Okay, what's the volume formula for a cylinder? Pi r square h. Okay, so substitute the values over here. Volume is 1029 pi is equal to pi into r square h. R is x. So x square into 3x. So pi and pi will get cut off. You see, that's the advantage if they given pi. It gets cut off. So we just have 1029 is equal to 3x cube. So take 3 down. So x cube is equal to 1029 divided by 3. So how much is that? 3 3s are, carry 1, 3 4s are, 3 3s are, 343. X cube is 343. So x is 7. 7 cube is 343. Okay, so we have the height, we have the radius. Therefore, radius is equal to 1 into x. That is 7 centimeters. And height will be 3 into x. That is 21 centimeters. Okay. So now since we have the radius and height, we can find the total surface area. So total surface area formula we have to derive. That is curved surface area plus the top surface plus the bottom surface. Totally 3 surfaces, right? Curved, the top and the bottom. Curved surface area formula is the circumference 2 pi r into h, the height, plus top is pi r square, and bottom is also pi r square. So there is 2 pi r square, top plus bottom. Take the 2 pi r common outside, so you have h plus r. Okay, so that's the formula. So now put the values. 2 into 22. Okay, you know what to do. Complete it. Tell me the answer. Okay, so this answer is 1232. Since it's centimeters, I mean it's an area, so centimeters square. Did you get this answer? Okay, so I hope cylinder-based questions are okay. I think we should do one hollow cylinder. See, hollow cylinder formula is very big, right? So you have to derive the formula. Instead of learning it, it's your choice. You want to learn it? Learn it. If you want to derive it, okay? A hollow cylinder, to find its total surface area, you have to add all the surfaces that are there in hollow cylinder. How many surfaces does a hollow cylinder have? All of you online, please put your cameras on. 4. Nobody's online, then I will cancel the class early. There are 4 surfaces here. There is the external surface area, there's the internal surface area, there is a top surface which is like a donut, and the bottom surface also which is like a donut. Okay, so totally 4 surfaces. So external surface area is 2 pi capital R into h, the same as what we've seen before. Internal surface area is 2 pi small r into h, because you have external radius and internal radius. Then the top, since it's like a donut, the area will be the outer circle's area minus the inner circle's area. Outer circle is pi capital R square, and the inner circle's area is pi small r square. So you subtract them, you will get pi capital R square minus pi small r square, or which is pi r square minus r square. And that is there on the top and bottom, so twice. So 2 pi r into r square minus r square. So this whole thing is the total surface area for a hollow cylinder. 2 pi h into r plus r plus 2 pi into r square minus r square. Okay. So which is that question that you were asking? 10th one. Look at the 10th one. Find the total surface area of an open pipe of length 50 centimeter, external diameter 20 centimeter, and internal diameter 6 centimeters. Whenever you see external and internal diameter or radius, that means it's a hollow cylinder, because there's internal and external. Okay. So what all values are given in this question? We won't solve it, but at least tell me what all values are given here. So what is 50 centimeter? Length, there is no L over here. What is that value? It's height. See, a length of a pipe, no? If you put the pipe standing up, that becomes a height, no? So take it as H, height. Height is 50 centimeter. Then you have external diameter. So we don't take diameter, we take radius. External radius and internal radius. External radius will be how much? 10 centimeter, half of diameter. And internal radius will be 3 centimeter. That's all we need, right? H, capital R, small r. You have to put in this formula and solve it. You know, do it fast. It should take you around 2 to 3 minutes. Do this question quickly. Question number 10. I'll just come in a minute.
We have to find total surface area.
Yes, total surface area. Question 10 in my book. Okay, I hope you're all getting an idea of what type of questions are coming over here. Sometimes it can be like this. This is a direct question where they're just simply giving all the values and saying find the total surface area. Okay. Now, sometimes the question will be melting, recasting some shape into another shape. In that, the formula you will take is number of smaller shapes is equal to volume of the bigger divided by volume of the smaller. Remember that formula, everyone? You take a big shape and you make it into smaller shapes. The volume of the big shape will be equal to the volume of all the smaller shapes. Right. So to find the number of smaller shapes, you just have to do volume of the big shape divided by the volume of the smaller shape or object. Then you have one concept, that is when you rotate or when you roll a circle or a cylinder or a cone, anything that has a circle on it. Okay. The circumference of the circle will be the distance covered in one revolution. If the circumference is 10 centimeters, then in one rotation or one revolution of that wheel, it will cover a distance of 10 centimeters. Okay. So what if it covered a distance of 20 centimeters? What does it mean? It went 2 revolutions. Correct. Because one revolution's circumference is 10 centimeters. And if it went 2 revolutions, then it would have covered 20 centimeters. Got it. So the formula is number of revolutions is equal to what? Okay. If that's confusing. Okay. Distance covered. As it rotates, what's the formula for distance covered? The number of revolutions multiplied with the circumference. See, say circumference is 10 centimeters. And if it went 2 rounds, how much distance it will cover? 20 centimeters. That's this. Number of revolutions 2. And if the circumference is 10, then the distance covered will be 20 centimeters. You understand? So this is a formula related to that. Okay, if it's rotating on something. So same way, in this formula, you can make number of revolutions the subject. So what will number of revolutions be? No, if this is a subject, number of revolutions will be 20 divided by 10. That is the total distance covered divided by circumference. You all getting me? Okay. Just write on this one formula. Let's see if there's a question on this. Okay, look at this question number 20. It's a little difficult question, little different. Let's not say difficult. Okay, let's see the question. The difference between the outer curved surface area and the inner curved surface area of a hollow cylinder is 352 centimeters square. If its height is 28 centimeter and the volume of its material is 704 centimeter cube, find its external curved surface area. Okay, so little different. What all is given? Tell me what all is given.
Thickness.
Thickness. What is this 352 centimeter square? Difference between external surface area minus internal surface area is 352. Yes or no? So whatever the external surface area and the internal surface area, if you minus that, you get 352. Then what is this 28 centimeter? Height. Okay, that's given directly. Height is 28 centimeters. And the volume of this hollow cylinder is 704 centimeters square. What do we have to find? We have to find the external surface area. Okay. What do we do? First, we see what we have to find and see what all we have, what all we don't have. So what's the formula for external surface area? external external circumference into height, 2 pi capital RH. So in this we have h, we don't have radius. Okay. All right. So we can't directly use it. We need to do something with that first formula. So we'll substitute the values, substitute the formulas over here. External surface area minus internal surface area. That means 2 pi RH minus 2 pi smaller h is equal to 352. Take 2 pi h common outside. Inside you'll have r plus r is equal to 352. In this, what all do we have? We have 2, we have
We have to
pi,
find
we have the height, but we don't have r plus r. Okay. So if we solve this, we can find r plus r. Okay. All right. So let's just keep that for now. Let's use volume. Since we have volume, volume is the derived value. We can use volume formula now. So volume is 704. What's the formula for volume? Hollow cylinder. External volume of cylinder minus internal volume. That is pi capital R square h minus pi small r square h. Correct? That's 704. So again, pi and h are common here. Inside we have r square minus r square. Okay, now look at both these formulas. This one, if we solve, we'll get capital R plus small r. This one, if we solve, we'll get capital R square minus r square. Okay, so let's do that first. We'll get this r square minus r square. Okay, I'm substituting the values in this. We'll have to do both. So we'll keep a little more space and solve both. Okay, you can actually start doing if you understood what to do, right? So there's no formula which will directly give you any value. If we use the first equation, we're getting capital R plus small r. If we do the volume formula, we're getting capital R square minus r square. But you should also keep in mind that what is this capital R square minus r square? It is capital R plus small r into capital R minus small r, right? A plus b also, a minus b whole square is, sorry, a square minus b square is a plus b into a minus b. See now, look, in this what we'll get is, we'll get capital R plus small r. That is this one. Somehow you'll be able to find both, or simultaneously you'll have to solve both and find it, okay? Okay, okay, just tell me what to do here. 7 and 28 I'll cut. That is 4. So now 2 into 22 into 4. 222 is 44. 44 into 4. 88, 176. So 176 into capital R plus small r is equal to 352. So capital R plus small r is equal to 352 divided by 176. And it happens to be half. So capital R plus small r is equal to 2. Okay. So same way we'll continue to solve this also. 22 by 7 into h we have 28 into r square minus r square is equal to 704. So here also 7 ones are 7 fours are. 22 into 4 is 88. 88 into r square minus r square is equal to 704. So r square minus r square is equal to 704 divided by 88. Look at the last digit. 8 into how much is 4? Huh? 3s are, anything else above that? 8 8s are 64. So let's try that. 64 plus 6, 7. Okay. So we got r square minus r square is equal to 8. Now what to do? We have r plus r, which is 2, and r square minus r square is 8. So we can write this as r plus r into r minus r is equal to 8. And here we have r plus r, which is 2. So 2 into r minus r is equal to 8. So r minus r is equal to 8 divided by 2, which is 4. Understood? Okay, so now we can do something with both these equations. Equation, we'll call it A, and equation B. Simultaneously, we can solve them. Add equation A and B. So r plus r is equal to 2. Capital R minus small r is equal to 4. So if we add both these equations, we'll get 2r is equal to 6. Therefore, r is equal to 3. Then if you substitute r in any one of the equations, in the first equation, we get 3 plus small r is equal to 2. It's going negative. So r is equal to 2 minus 3, which is minus 1. Something is wrong. We should never get radius in negative. Right? It won't happen. It's not supposed to be plus. It's supposed to be minus here. Okay, it doesn't look like a very big mistake. I think we can fix it. Minus, 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 minus. So here also in place of, yeah. So r plus r is what we don't have. R capital, plus we don't have. In place of the small r, in place of the minus, we'll put 2. So capital R plus r is equal to 4. And capital R minus r is 2. Yeah, now it will come. So 2r plus r is 6, r is 3. And this part will go wrong. 3 plus r is equal to 4. Therefore, r is equal to 1. Okay, so we got the external radius 3 and the internal radius 1. It's not over. After this, we have to find the external curved surface area. So that is just this formula. 2 pi capital R into h. We have the capital R, which is 3. We have the height, which is already given as 28. We can find the external surface area. Okay, all of you do it.
T2.
I didn't hear anything, Anna. Is there something? Unit?
So 528.
Centimeter?
I got 352.
352. Okay, 2 people got 528. External surface area is equal to 2 pi capital R into h. That's 2 into 22 upon 7 into 3 into 28. 7 ones are 7 fours are. So yeah, check your calculation, Anna. This is what you're supposed to have.
Yes, and I got this 528. And I did 2 pi r h minus 2 pi r h. So I got it wrong.
Now that's a different formula, right? It is our external surface area. So just 2 pi r h. Okay. See, formulas,
Yes, and I got.
yeah, derive it correctly. And then, like, this is like one tough question because there's so many things. No, you have two equations and simultaneously you have to solve it. No? So if it comes like this, also you should be able to solve it. See, once you have understood this first exercise, no, the other exercises will just go on easily. The concept is here in this first exercise. Then in the next exercise, you just have more formulas. Okay. The next exercise is about cone. And then the last exercise is about the sphere. Sphere also, there is different types of sphere, okay? You have a hemisphere, then you have a hollow hemisphere, okay? So that will, again, just formulas are there, but concept is same like what we've been doing. Then they normally mix two solids. Like either you melt a sphere and make it into a cone, or you join two different or three different shapes together and make a different shape. See, like this is a combination of a cone and a sphere. So they'll ask you what is the external surface area, what is the total volume. See some shapes like this. So here you have more surfaces now. You see, there's one surface, the round one, then this flat ring-like surface, then the cone surface. So there are surfaces where you have to derive formulas for this. Okay. So that's this chapter. That's why this chapter is a little confusing. Okay, all interesting shapes are there. Okay, you can see in the diagrams. When a ball is put in the water comes up. By what level it came up? You understand? So the level of water that came up, the volume of water that came up will be equal to the volume of the ball. Right? Whatever the volume of the ball, that much water will come up.
Yes.
Those concepts. What is this? Looks like a coffin. So this is a cuboid and a hemisphere.
All
It's like a prism, sorry, hemisphere prism, like, or a semicircle prism. Okay, anyway, so like these different shapes to find their volumes and surface area. Volume is okay. You just have to add both the volumes. Surface area means you have to find all the surfaces and then add all the surfaces together. How many surfaces does the shape have? This side, behind, underneath, then two rectangles and then one curved surface. Okay. Okay. So you have to see the shape in 2D shape. You have to look at it in 3D shape. You have to imagine some things. They all like these type of questions. Okay. So just preparing you for what is ahead, not scaring you. But yeah, this is like the highest level of thinking in your maths textbook to be able to do these sums. Okay. And not everyone might be able to do it, but those of you can, you do this, you'll get that extra mark in your exam. Okay, we'll end with this because I believe we'll see you on Sunday. Yep. All right. Bye, everyone.
yes.
Bye. Okay, listen. Let's do this question number 13 from here. A vessel in the form of an inverted cone is filled with water to the brim. Its height is 32 centimeter and diameter of the base is 25.2 centimeter. 6 equal solid cones are dropped into it so that they are fully submerged. As a result, 1/4 of the water in the original cone overflows. What is the volume of each of the solid cones submerged? Okay, what did you understand from this? The cone is like this. Correct? Inverted, it's filled with water. And into this cone, they drop in what? 6 solid cones. And when they drop these 6 solid cones, what happens?
So what they submerged?
They fully submerged means, yeah.
Water rise.
Okay, they went inside. What happened to the water? Water overflowed.
Rise
How much of the water overflowed?
is equal to the volume of cone.
Not the whole volume of the cone. All the water did not overflow. Okay, 6 cones correct. But inside from the cone, how much water came out? 1/4. See, as a result, 1/4 of the water in the original cone overflows. Okay, so that means what? What statement can we come up with this? Yes. So volume of 6 small cones is equal to 1/4 of the volume of the big cone. Does this make sense? Because when they put those 6 small cones inside, 1/4 of the volume of water overflowed out. Yeah, this is your equation. So small cones volume formula is 1/3 pi r square h. And here this is 1/4 into 1/3 pi r square h. Okay, I'm just using small r h for the small cone and capital R and h for the big cone. Do you understand the formula, everyone? The equation? Okay, so now we put all the values. What all do we have? The question is what? They're asking what is the volume of each of the solid cones submerged. So we don't need to find pi and r and all over here, r and h. We have to find volume of one small cone. Okay, so let us actually come up with a better formula. We want to find volume of one small cone. So what is volume of one small cone? This is volume of 6 small cones, 1 by 4 into volume of big cone. So volume of one small cone will be 1 by 4 volume of big cone, divided by 6. Yeah. So divided by 6 means 1 by 6 into 1 by 4 into volume of big cone, which is 1 by 3 pi r square h. Yeah. Did you understand this formula? 1 by 6 parts into 1 by 4 of the volume of the big cone. Now we have the radius, we have the height. Radius is how much? Radius, they've given diameter 25.2. So it is 25.2 divided by 2. And the height is 32. So you can put these values in the formula. 1 upon 6 into 1 upon 4 into 1 upon 3 into 22 upon 7 into 252 upon 2, sorry, upon 20, right? If you move the point one place forward, whole square. So again, 252 upon 20 into the height, which is 32. You solve this fraction, you'll get your answer. Write this much down and solve it and tell me what you're getting. Okay, for those of you who didn't get, just watch how I'm cutting. So 4 and 32 we can cut in 4 tables. 4, 8 is 32. Then what else? 3 and 252. 3
7
8s are 24 and 3 4s are 12. 7 we can cut with 84. 7 1s are 7, 7 2s are 14. Then 6 and 12 we can cut, 6 2s are 12. And then 2 and 20 it becomes 10. So you try to make the denominators 10. Here also 20 and 8 we can cut. So 4 and 10. Okay, so that way we've cut all the denominators. Don't cut anything more. Otherwise the 10 will go up. You'll get 5 or something. So now you just multiply all the numerators. The numerators are 22 into 252 into 4. So 4 into 22 is 88. So you just have to do one calculation, that is 252 into 88. 8 2s are 16. 8 5s are 40 plus 1. 8 2s are 16 plus 4, 20. And since it's again with the 8, 2016, written again. Right? So 6, 7, 1, 2, 2. So 22176 divided by 10 into 10, which is 100. So the answer is 221.76 centimeter cube. We will do this 14th question next. Okay, so what is important when you're doing these sums is deriving an equation. Yeah, getting this whole equation, understanding what is this. So volume of 6 small cones was equal to 1/4 of the volume of the big cone. And then from that you derive whatever is asked. Yes, volume of one small cone. Okay, we'll go to the next question, number 14. The volume of a conical tent is this much, and the area of the base floor is 156. Okay, what does it mean now? This is the conical tent. Okay, and the volume is given. Volume is 1232 meter cube, and the area of the base floor, that means this base, it's a circle. So the area of that circle is 154 meters square. Calculate the radius of the floor. Radius. Calculate the height of the tent. Calculate the length of canvas required to cover this conical tent if the width is 2 meters. Okay, so you need like this long cloth. The width of this cloth is 2 meters. They're asking what is the length. You understand? This is the question. Is everyone clear with the question? Read the question again, see whether you understood or not. Yes, everyone clear with the question? All right, how do we start off? Okay. Okay, so since the base is a circle, we can use the area of circle formula. Area of circle is pi r square. And we have the area of the circle, which is 154 is equal to 22 by 7 into r square. So that way you can find the radius. Okay. Once you find the radius, next you have to find the height. To find the height, we'll use the volume formula. Okay, volume formula, volume is equal to what? 1 upon 3 pi r square h. Correct? Volume of cone. In this, we have volume. We got the radius. H is missing. We'll find that. Okay, see, I'll just highlight here. This is what we have to find. Here, this is what we have to find. Okay, do these two first, then I'll explain to you the third part.
Sir, r square is 1, so r will be 1 only, no?
Yeah. You got R as 1.
Yes, r square is 1.
You got 7. Okay. Area, no? You're covering the outside. The surface area of the tent should be equal to the surface area of the cloth that you're using. Okay, did you all get A and B? What is the radius? 7. Here, what's the height? 24. What's the unit? Everything is in meter.
Meter.
All right. For the third part, the area of the question is how much length of cloth. They're asking length, but actually you need a certain area of cloth because cloth is measured in area. So whatever the area of the curved surface area is, that is the area of cloth that you need. Correct? So we need to first find the curved surface area of the tent. And that area of cloth is required to be bought. Okay, the canvas required. So now we have area here, and this is in the shape of a rectangle. If you see the cloth, it's in the shape of a rectangle. So area is equal to length into breadth. Where we have the breadth, we have to find the length. We have the area. Area is the curved surface area. Okay. So we have the curved surface area is equal to length into breadth. Okay. We have to find the length. What's the formula for curved surface area? Pi square L, pi RL. Pi RL. So first you have to find L. L square is equal to h square plus r square. Pythagoras formula. Now we have to find the curved surface area. $275, no? Meters. Okay, I'll explain to you the next set of formulas, that is sphere. A sphere is like a ball. Right. So you have just two formulas. Volume formula, which is 4 upon 3 pi r cube. And second formula is there's only one surface. The whole curved part is one surface. So that is total surface area, which is 4 pi r square. No way to derive this or anything. You just memorize these two formulas. Okay. Volume is 4 upon 3 pi r cube. 4 upon 3 pi r cube. 4 upon 3 pi r cube. Total surface area 4 pi r square. It's 4 times the area of a circle with the same radius. You see that? If a circle had the same radius, it would be pi r square. And this is 4 times that. So just remember that much. Now, other than a normal solid sphere, you also have a spherical shell. That means a hollow sphere. Hollow sphere. Like actually, a football is like this, right? There is a material outside, inside is hollow. So for that, if you want to find the thickness of the what is this? The material, you have to do capital R minus small r, right? Capital R minus small r. And if you want to find its volume, you have to do the outer circle, outer sphere's volume minus the inner sphere's volume. That is 4 upon 3 pi capital R cube minus 4 by 3 pi small r cube. So when you take common outside, you'll get this formula. 4 upon 3 pi capital R cube minus small r cube. Is that clear? Any doubt? That is the volume of the material in the spherical shell. So that's all the formulas for a sphere. Then you have a hemisphere. Hemisphere is a half sphere. Half sphere. So for a hemisphere, what will be the formula for volume? Volume is the amount of quantity material that's present. So a hemisphere will have exactly half of a full sphere. So what's the formula? Divide this by 2. So it will be 2 by 3 pi r cube. Correct? Next, for surface, how many surfaces do we have here? There are two surfaces. One is the top flat surface and one is a curved surface. Okay. So we have, let's separately find curved surface area and then total surface area. Okay, just rejoin the meeting. Yeah, what's the formula for the curved surface area? See, we know the total surface area of a sphere. The full surface is 4 pi r square. So now the curved part is just this much here. So half of 4 pi r square, that is 2 pi r square. Okay, and then now you have this flat part. The flat part is in what shape? Circle. So area of circle is pi r square. So total surface area will be the curved surface area plus the flat surface area, which is equal to what? Yeah, 2 pi r square plus pi r square is 3 pi r square. Clear? Okay, then you have a hollow hemisphere. Okay, so you basically have to derive formulas like how we are deriving. There's no point mugging up these formulas because there's so many. So hollow sphere, hemisphere. So what will be the thickness? Capital R minus small r. Volume will be outer hemisphere minus the inner hemisphere. We have the volume of the hemisphere, right? So 2 by 3 pi r cube minus 2 by 3 pi r cube. Then surface area. How many surfaces are here? There's 3 surfaces. The outer curved surface, the inner curved surface, and this ring. Okay. So outer curved surface area formula we have 2 pi r square. Inner curved surface area also will be 2 pi r square. And then this ring will be the outer circle minus the inner circle. Outer circle is pi r square minus the inner circle pi r square. So like that you have to derive the formulas, okay? So I'm not even writing the formulas. As it comes, we will do it. Just write these main formulas. From this only you're deriving everything else. Okay, after this, do this third question here. A spherical ball of lead has been melted and made into identical smaller balls with radius equal to half the radius of the original one. If this one's radius is r, then the smaller ball's radius will be r upon 2.
R upon 2.
How many such balls can be made? So what's the formula for number of balls that can be made? Volume of the big sphere divided by volume of the small sphere. Correct? We have done this number of things before, no? Big one's volume divided by the small one, we'll get the number. Okay. All right. So we don't have the number. And let's don't find separately volume of big sphere and separately. We just put the formulas. So volume of big sphere is 4 by 3 pi r cube. And the small one is 4 by 3 pi. What is r for the small one? R upon 2 whole cube. Correct? We're putting the radius, which is half. So here we can cut 4 by 3, 4 by 3. Pi and pi we can cut. Even the r and r we can cut. So r cube and this r cube gets cut off. So what we have remaining? Numerator is 1, denominator is 1 upon 8. Not just 8. Correct? The 8 is in the denominator. So this, if you bring it on this side, it will become 1 into this 1 into 8 upon 1. Which means 8. Number of balls, 8. Clear how to do it? There was no substituting anything. Nothing was there also. Just have to make the formula like this, derive it and put it. Okay, let's do this last question here. The surface area of a solid sphere is increased by 21% without changing its shape. So shape is same. That means it's a sphere only. Only thing now it's a bigger sphere. So the bigger sphere has a, see, shape is same, size is different. Okay, similarity we learned. So here also shape is same, it's a sphere. You're just increasing its surface area. Now, what will be the percentage increase in its radius and what will be the percentage increase in its volume? Okay, so how do we do this? So you have the small sphere and the big sphere. So let's write all the values that we have. So first we'll see surface area. For the small sphere, if the surface area is x, then the big one surface area is what? Okay, if you say 100x, then this will be 121x. Correct. If you add 21%, it becomes 121x. So like that, you have to find for everything. Radius and volume. Here, if the radius is r, then what is the radius here? Here, if the volume is v, here, what is the volume? In percentage. Okay, so take 100. This is 100. This is how much? This is 100. This is how much? Okay. So since surface area is given, we'll first use surface area volume. Surface area of the small divided by surface area of the big. Make a ratio like this. Surface area formula is what?
4 pi r square.
4 pi r square upon 4 pi r square. Small one will use small r, capital will use small, big will use capital R. Okay, so we have the surface area of small to big. Small is 100x and big is 121x. Here we cut the 4 pi, 4 pi. So we have r square upon capital R square. To remove this square, what do we do? We'll square root both sides. Here x and x also will get cut off. So square root both the sides and we get 10 upon 11 is equal to small r upon capital R. Okay, so what we got is a ratio between small r to capital R. 10 is to 11. We're going to use this now for all other calculations. Is that clear, everyone, first? Okay, write down this first and then we will find the percentage increase in area and volume. Okay, we're going to the next part. Find the percentage increase in its radius. Okay, we have this actually. So the radius was 10, it became 11. How much is that how much is that of an increase? The increase in radius is how much? Yes, so increase percent is the increase divided by the original value into 100. The increase is 1 divided by the original value is 10. Remember this percentage formulas. Profit percent is what? Profit upon CP into 100. Same way, increase percent is increase upon the older value into 100, which is 10%. Okay. Next, volume increase. So we need to find what is the increase in volume. So volume of the small divided by volume of big is what we have to find. A ratio. Volume formula is what? 4 upon 3 pi small r cube divided by 4 upon 3 pi capital R cube. Cut off all the 4 by 3 pi's. Okay, we have the r's. So volume of small to volume of big will be 10 cube upon 11 cube. That is 1000 divided by 1331. Okay. So here, what is the increase in volume or increase percent of volume? 331, sorry, 331 divided by the original value, which is 1000 into 100. Two zeros, 331 divided by 10, which is 33.1% increase. Is everyone clear with this? Do it. Okay, all of you just do this 9th question now. This is metallic sphere. It's melted and made into a cone. So it's a combination of sphere and cone. Do this question right now. That's 4 pi r square is equal to 1256.
So we have to take as pi 3.14.
Oh, they told to take that. Okay. So 12.56 into r square is equal to 1256. So r square is 1256 divided by 12.56. So r square is 100. So r is equal to 10. So number of cones is equal to volume of the sphere divided by volume of the cone. So
Sir,
volume of this, yeah, derive the formula. 4 upon 3 pi r cube divided by 1 upon 3 pi r square h. Derive the formula like this. So here 3 and 3 will get cut, pi and pi will get cut. So we have 4 radius, okay, 10. 4 into 10 cube divided by 2.5 square. That is 25 upon 10 into 25 upon 10 into height 8.
5,000.
4,000 divided by 25. Correct? So 25 ones are 25, carry 15, 150, then 6 are 160, no?
Sir, 80 I'm getting. So first I did the 25 into 25 into 8. So I got 5,000. I divided by 100.
Okay. Yeah, 2 is also there here. So 160 divided by 2. 80 is the answer. Okay? Yeah. All right. So you understand how this chapter is, right? I think we have done all types of questions from here. Questions without values, some questions with values, and then finding number of shapes, number of this thing. And okay, look at this question number 7. A wooden toy is in the shape of a cone mounted on a cylinder as shown in the diagram. Understood? Cone on top, cylinder at the bottom. If the height of the cone is 24 centimeter, and the total height of the whole toy is 60 centimeter, and the radius of the base of the cone is twice the radius of the base of the cylinder, which is 10. So if this is 10, then this will be 20. Yeah. Find the total surface area of the toy. Okay. So you have to count how many surfaces are there. This is your toy. Now you have to either find volume or you'll have to find surface area. Volume is fairly simple. You just find the volume of the cone, find volume of the cylinder, and add both. You'll get the total volume. You understood? If the question is to find the total volume of the shape, what you'll do? Find volume of cylinder, volume of cone, you have the formula. Find volume of cylinder, you have the formula, and add both. Is that clear? But surface area, you have to find how many surface areas are there, how many surfaces are exposed, like outside. Okay, so let us find all the surfaces. So one is this part, the curved surface. Then next surface is this circle here. What shape is that? That bottom part of the base. It's like a donut. You can't take the whole the base because that cylinder is blocking half of it, no, for that circle. See, when they ask surface area, you're only calculating the external surface area, whatever is exposed to the atmosphere, whatever you can see. See, if I take something like this and I put over here, see that surface is gone, it's covered. So that surface should not be included in the total surface area. You have to minus it off. So here also, you see that ring, that circle, that small circle over here, that one's area is not included in the base of the cone. So you're only finding this circular part in the donut part. Is that clear? Next, for the cylinder, how many surfaces are exposed? The curved surface and the bottom surface. Imagine in 3D. Okay. What about the top surface of the cylinder? That's covered because the cone is sitting on it. Understand? So like this, you have to find each surface separately. Now, what all values are given? Height of the cone is 24. So from here till here, this much is 24 centimeters. And what is the 60? Huh?
Total height of the toy.
Total height from here to here. This whole thing is 60. Correct? So cylinder's height will be how much?
60 minus 24.
60 minus 24. That is 36. Is that clear? Okay, then what else is given? The base of the cylinder is 10 centimeters. So this much here, or I'll draw it here. From here to here, that is 10 centimeters. And this much from here till here, that is double of that, no?
Right.
So that
20
is,
centimeters.
that's it. Do we need anything else? No, we have everything that we need. Okay, so now let's find the total surface area. So you have to derive the formula. Starting from top. So first is what? The curved surface area of the cone. CSA of the cone. Plus this ring here. The base of the cone, which is partially covered, right? So that base, what we'll call that? We'll just call it base of cone. Plus curved surface area of cylinder plus base of the cylinder. These are the four surfaces. Okay, now formulas for each. What is curved surface area of cone? Pi RL. That's the formula. Plus this base of the cone. Pi r square is the whole circle, the whole base. But now that base is, you've taken out a portion of it. So it's the outer ring minus the inner ring. Area of the outer ring minus area of the inner ring. That will be the area of that remaining base. Understand? See, if there's a full circle, what's the formula for full circle? Pi r square. Correct. But now you take out a portion of it like this. So you have to minus that area. So this is the formula of the base. Did you all understand? So that is pi into r square minus r square. Okay. That is this donut. Next, curved surface area of cylinder is what? Cylinder's curved surface area is circumference into height. 2 pi r into h. We'll use capital R for, let me just change the alphabet so we don't get confused. Capital R for the cone, capital R for the cone, small r for the cylinder. So cylinder's curved surface area 2 pi r, that is the circumference into the height, plus base of the cylinder What shape is the base of the cylinder? Circle. So pi r square. Did you all understand how we derive the formula? Any doubt, anyone? Ryan, cameraman. Okay, so we have one missing value here, that is L. L is the length of the hypotenuse. So we need to first find that. So before you do this, find L. L square is equal to h square plus r square. So L square is equal to height, which is 24 square, plus radius, which is 20 square. Is that clear? So using Pythagoras formula, find L and then put in this formula. Now in this formula also, we have to simplify this. How can we simplify this formula? Okay, pi is common in all. Take out pi. So then what's remaining? RL plus r square minus r square plus 2RH plus r square. Right? Nice, big, interesting formula. Put the values over here. Okay. All right. I want you to complete this now. Find L first. Put that L in this formula and find. Okay. So the radius, what we have written, is not correct. I'll tell you why. The radius of the base of the cone. What did we take? Which alphabet did we use for that? Huh? Capital R. Right. The radius of the base of the cone is equal to what? Is equal to twice the radius of the base of the cylinder. That means 2R, which is equal to 10 centimeters. You see that? What does it mean? Capital R is 10 and 2R is equal to 10, which means R is equal to 5. Okay. Yeah, so we have to be very careful with the question because sometimes it comes like this. Do you understand or not? Okay, so we'll have to just change capital R and small r. It's not 20 and 10, it is 10 and 5. What's the answer behind?
Everyone got the same.
Huh?
This question is not in.
You don't have this question.
Everyone got the same.
Okay, what did you get, everyone?
2 basic 0 1.
You all get this answer? Okay. All right, so what's the unit?
2260.80.
Put 80 because paisa. Oh, wait, not rupees, sorry. I thought it's rupees. If it's rupees, then you have to put 0. If it's not, then 0.8. Okay. What's the unit? What's the unit? Wrong. 0. Centimeter square, you're finding surface area. Area, no? Area is square. Volume is cube. Aman, correct or not? No, you're finding surface area. Okay. Yeah, so this is one type of question. The other type of question is where you use this concept, volume is equal to area of cross section into height or into the third dimension. Do you know this concept? We have used this concept to figure out the formula for volume of cylinder. How did we get volume of cylinder? Cylinder. Here, this is a cylinder. Okay, how do you find the volume of cylinder? We found the area of this shape here. What is this cross section? What shape is this? Circle. This area of cross section is pi r square into height h. That's how we got the formula for volume of cylinder, pi r square h. Correct. So we're going to use this concept to find volume. First, you get the area of cross section of whatever shape is given and multiply that with the third dimension, whatever the third dimension is. So look at this question here. The cross section, this is question number 10. Do you have this? See the diagram if you have in the book. The cross section of a railway tunnel is a rectangle 6 meter broad and 8 meter high, surmounted by a semicircle, means having a semicircle on the top. Done. 6 meter high, surmounted by a semicircle as shown in the figure. The tunnel is 35 meters long. Where is the length over here? Why is it not mentioned here? It's 3D. It's going into the book. Okay, 35 meters going behind. That's your third dimension. Find the cost of plastering the internal surface of the tunnel. Okay, so internal surface of the tunnel means this part, not the base, because you don't plaster the bottom. You only plaster the walls, right? So find the means you have to find the surface area of the inner part. How do you find the surface areas? You just find this length and then multiply it with the 35. Look, two formulas are there. One is volume, which I said over here. What is the question is find the cost of plastering the internal surface at the rate. So they have not asked to find the volume, but if they asked you to find the volume, how would you find the volume of the tunnel? Huh? Yeah, you'll find this one's volume. This whole thing's area, and then multiply it with the length. It's like a bread loaf. Saw that? Okay, so you find the area of the cross section and multiply it with 35, you'll get the volume. Now, how do you find the surface that you're going to plaster? So the surface that you're plastering is where? It's this much, what I'm highlighting here. That is the surface that you're plastering. So for that, you'll have to find this one's length and multiply that with 35. It's like curved surface area. How do you find the curved surface area of a cylinder? You'll have to find the circumference and multiply that with height. Circumference means the length of this border. Same thing here also, you have to find the length of this border that you're plastering and multiply that with that 35 meters. Is everything clear how to do this? So how do you find this length? So we know this is 8, this is 8. How much will this be? What is the radius of the semicircle? So this base is 6. That means this will be 3. Right? So we have to find half of that circle. It's a semicircle. So half circle's length. What's the formula? See, this is a half circle. So what will be the circumference of this half circle? Circumference formula is 2 pi r. That is for full circle. But this is half circle. So that will be just pi r. Okay, pi's value is not given. So that means 22 upon 7 into 3. That will give you the length of this half circle. So that you have 8 plus that value plus 8. That will give you the full length. And multiply that with 35. You will get the total curve surface. Total surface area inside. Internal surface area. Okay. And then they're saying it costs you rupees 2 rupees 0.25 for every meter square. So whatever the meter square is, whatever the internal area is, you multiply that with 2.25 to get the cost. All right. So try the question that is in your book. You can actually draw this also. Just draw this diagram and write down these points. You can use that.